Okay, I'm going to assume you don't have the Arduino software installed, so we're going to go with your Arduino not hooked up to your computer, and you can download the Arduino software from arduino.cc. Basically, we'll just click on this, extract it. I'm going to make this pretty simple. Just throw it on C and extract it. And I'll go and pause the recording here because this is boring to watch. Just about done. Alright, done. Now, what we'll go ahead and do is you can go ahead and plug in your Arduino to the USB and let Windows detect it. Then we'll go ahead and navigate to wherever you installed it to, and you can launch the Arduino software. What we'll then want to do is go to Tools and choose your board, whichever one you have. I have the Mega here. You'll also want to go to Tools and make sure you have the right serial port. A lot of computers will have a COM1, which will be your serial port, but you'll want to choose whatever other COM port you have. Okay, then I had you download two libraries, one being the Dallas Temperature Beta, which I have for some reason an extra copy up here. What you'll do is just open that, extract all. You'll actually put it in your users, my documents, Arduino, libraries folder, and then hit OK and extract it. And that's done. And then we'll do the same with, should be one wire. Click on that, extract all, browse to documents, and Arduino, and libraries. Okay, extract it, boom, done. Now, if you go back to Arduino software, and you go to Sketch, Import Library, you'll notice that the one wire and Dallas Temperature Sensor are not actually here. Anytime you add a new library and you have the Arduino software open, you do have to close it and then reopen it. And what do we got here? It appears that in someone's infinite wisdom, they inappropriately named this folder. So just change those dashes to underscores. We should be fine. Close that, and relaunch Arduino. No error that time, and you'll see both libraries down here in the contributed section. Okay, so in this little sketch pad area here, where we're going to write our sketches for Arduino, all our sketches have to have a minimum of two things, and that is a void setup, and some curly brackets there, and a void loop. Again, curly brackets. Now, basically, the setup is kind of defining some things that it runs once whenever the board is launched, started, or restarted, and whereas the loop is just what it repeats over and over and over until the end of time or until it's told otherwise. Now you can create other variables, like I can put, void whatever, and then have that, and I can call it later, but right now we'll kind of stay away from that. Every programming language has their kind of hello world sketch, or program that you write, be it C++, whatever. With Arduino, that cliche little piece of code is the flashing LED. So we'll go ahead and knock that out, get it out of the way to say we've done it, and then we'll move on to actually making this temperature probe do something we want it to do. So to make a flashing LED, we'll go ahead and declare something up here. We'll declare an integer, and we'll call it LED pin, and we'll make it equal 13. And then we'll add a semicolon. Semicolons are necessary at the end of commands, because that actually lets it know that it's the end of that command. what we're doing here is we're giving pin 13 on our digital pin 13 on your Arduino board a name. We're naming it LED pin. And this is a kind of standard naming convention in Arduino to start something with a lowercase, and then when the next word starts, start with an uppercase. And I'll show you the reason we're doing this here in a second. So, and in the setup, we want to do pin mode, and then set LED pin as an output. What that's doing, let me clean this up, just make it look a little bit better. We're basically saying pin 13 is an output. Again, LED pin is just an alias at this point for pin 13. And again, we could have not done this and just done pin mode 13 output, but you'll see here in a second why it matters. So now we want to go ahead and actually make this thing turn on and off. So we'll digital write LED pin high. High being on, low being off, or high being a 1, low being a 0 for digital. Really, it's high being positive voltage and low being ground. Is the other way to look at it. Then we want to set a delay. So it waits, well, let's say a second and a half. Then we'll want a digital write LED pin low. And then delay it again before it restarts this loop again. So what we're doing is we're naming pin we're naming pin 13 LED pin. We're telling it that LED pin is an output, so it's not expecting a signal to come in or anything like that. We're just going to be putting out to it. We are then turning it on, waiting a second and a half, turning it off, waiting a second and a half, turning it on, waiting a second and a half, repeat, 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 repeat indefinitely. The reason I chose pin 13 is I'm assuming y'all don't have just a bunch of LEDs laying around. Luckily, on an Uno, a Mega, and a Do, pin 13 is already tied to an LED that is on the board labeled L. So it's already got a resistor in place and everything else. So we can just make that LED blink, which is what we're going to do. So what we'll do is we'll verify first, make sure we don't get any errors, make sure we didn't misspell anything. And you'll see it check here. Checked out OK. We'll go ahead and upload the sketch. Once this says that it's done, yep, thank you, you should be able to look over at your Arduino now and see a flashing LED light. So you basically come on, wait a second and a half, turn off, wait a second and a half, come on. That's it, done. Okay, that was fun. It's kind of boring. Let's actually do something that we want it to do. Go ahead and take your, let's power your breadboard that you already had everything else plugged into. So let's take a negative from the breadboard, from that negative bar, and we'll plug it into the negative on the Arduino. And then we'll take the positive from the positive bar and plug it into the 5-volt on the Arduino. Then go ahead and take the signal pin from the DS1820 B20, which was the yellow pin that we plugged into 3E. Go ahead and plug in a jumper from anywhere in that 3 row and plug it into your Arduino on digital pin 3. Okay, once you have those 3 wires plugged in, let's go ahead, and the other thing I had you download was this one wire address finder. If you open it up, it'll tell you right here that plug it into pin 3. So what we did, and then we'll go ahead and just upload that. Once this is complete, done, go to Tools and Serial Monitor. What you should see here, yep, boom, right there. We need this line. This is the address of your, it's basically the physical address of your temperature sensor. If you have multiple temperature sensors in a chain, you'll get all of them. But for right now, we'll just use this one. So just copy that, and then go and put that in a notepad. So we have that saved. And we're done with that sketch. Let's go ahead and go back to this one, and we'll start from scratch. So what we'll need to do is we'll need to go ahead and import a library, the Dallas temperature control, and import another one, the one wire. One wire is a bus technology made by Dallas Semiconductor for a lot of different devices they have. Most likely we're just going to use it for temperature and you'll be fine, but no, it's for other things as well, where you can daisy chain multiple devices and pull it off of one single wire. We could do multiple temperature sensors and use one signal wire to the Arduino and not have to use multiple inputs, so it's kind of handy. And so one wire this library is just a group of commands that are associated with keywords that we can use it much more simply than having to recode. We don't have to reinvent the wheel. Same thing with Dallas temperature sensor. You can do it without them, but the code ends up being really long. So somebody else already did all that work for us. So what we're going to go ahead and do is we're going to go ahead and define a temperature bus. So let's use a temp bus. And we already have that pin plugged into 3, so we'll just do 3. And by the way, these slashes just allow you to make a comment, so you can do double slashes. So it declares pin 3 as a one wire bus. Okay, then we need to actually push that information to one wire. So one wire. This is basically calling this library, so it's case sensitive. So one wire. So then there's a keyword inside one wire, which is basically a command called one wire. Actually, sorry, take that back. This is actually a variable we're declaring for ease of use. I'm just going to call it one wire. And then we need to tell it the information we just gave it above, which is temp bus. So we're basically saying, hey, one wire, you're on the temp bus, and temp bus is 3. So we're good there. Now, we need to pass that information to Dallas temperature library. And we need to give this basically a name, a common name that we can use as well. We'll call it temp sense. Or how about T-sensor? Makes sense. And then basically we're going to say you're going to get your information from one wire, which is what we called it right up here. So you could call this, Steve, and then this would become Steve. But again, trying to give it names that we can remember. Not saying Steve is not a memorable name, but not very intuitive when it comes into what we're doing here. Then there's a keyword in Dallas temperature called device address, and we have to give it a common name as well. For the probe that we're going to be using here, I'm using mine for my tank, so I'll just call it tank, and then equals curly bracket. This guy, paste it in here, and close curly bracket, and okay, so now we need our void setup. In inside our void setup, we need to go ahead and do a few things. First of all, we're going to want to see this printed somewhere, so we're going to print it out to the USB cable. To do that, we'll use serial begin, which is just a common Arduino command, and we'll just set the baud rate to 9600 because that's default, and this is just going to start USB serial. Then we want to start the sensors, which we called up here. Basically, we're going to initiate this. So we'll do T sensor begin. And that should be all we need to set up. Now, what I'm going to go and do here, just kind of to make an example of something, and also to make a little bit of ease of code here in a second, we're going to create another variable. We'll call it void echo temp to serial. And then we'll want basically pull device address, which is this up here, and we'll want it to pull a variable, which is device address, which is really going to pull the variable tank. In this case, it just means any device address. So if we had 20 different sensors, it would pull them each one by one. So what we'll do is inside there, we'll create a float. We're not going to need an integer because this is going to be, 78.6 or what have you. And there's a command called, well, first we need to give it a name. What are we going to call this float? Well, it's going to be the temperature in Fahrenheit. We'll just call it temp F. And that will be T sensor, which again, anything that we're pulling from the this instance of Dallas temperature will be called, we're calling it T sensor, because I don't want to type it Dallas temperature every time. And there's a command called get temp F, and then from device address, so any device address. So what that'll do is it'll pull the temperature in Fahrenheit from whatever's here in device address, which is tank, which equals this. And instead of having to type that out every time, we're just calling the variable. So if your temperature sensor for some reason comes unplugged, it shows up as negative 127 degrees Fahrenheit. So in case that happens, let's just do if temp F is less than negative 100. We'll want it to put the brackets here. Serial print line, print ln, will print something to the serial monitor, which we used earlier, but put a caret return at the end. There's other ways to do this, which I'll show you here in a minute, that actually use a little quicker, use less space. And we'll want it to print sensor disconnected. And go ahead and, so yeah, if this happens, it'll do this. Well, else, because we want to do something else if it does get a signal, else we'll want it to serial print F colon space also want it to print float that we created, which should be the temperature in Fahrenheit. So again, this is a command that we can call, and it will do that, what we just told it to do, basically. And the convenience of these brackets, it'll also tell you where the opening and closing brackets, so you can always make sure you have enough brackets. But now let's make our loop. And this is what we'll be running constantly. So we'll do void loop, and we're going to start our curly braces, and do serial print instead of print line, and then we'll have it print getting temperature from probe. Now if you do that should get us carriage line return as well, instead of doing print line. A little bit quicker, not really a big deal in most cases. Then what we want this to actually do is we want to actually request the temperature from the temperature sensor. So that's in the Dallas library, so we'll do tsensor, and we will request those temperatures. And then we'll do, let's see. Basically all these serial prints are just good for kind of debugging. And now we'll want to call this command, this echo temp to serial that we created. So we'll just do echo temp to serial, and then remember it requires a variable here, the device address, which we named tank, and there we go. And then let's just go and throw in carriage returns here just to pretty it up. And so we don't spam the serial console that we'll be watching. Let's go and throw in some delay here. 3 seconds. 3 seconds. There we go. Let's make sure we spelled everything right and didn't forget anything. So we'll where is it complaining? Void does not name type. Does not name type. How is it name type? Oh, there's a capital void somewhere. Oh, there it is. Ha. Yeah. That is the problem. Okay, good. That checked out okay. Let's go ahead and upload it. And when this is done, it should give us a done down here. Thank you. We'll go to tools and we'll go to serial monitor, and there we go. Right now, obviously, this is just sitting out in my on my desk here, so kind of cool. But I can like pick it up, hold it in my hand, just kind of squeeze for a second here, and we should see the temperature start going up. Yep, there we go. 80, 84. I'll just go and let go now. So that's fun. We have it getting the temperature. We have it displaying the temperature. Great. Let's go ahead and I'll give you a preview of some things that I've already got mine doing that actually have mine doing something else, but this will just kind of give us a hint, and we can go from there. We're going to declare 3 integers here. We'll call it 1 high temp LED, and we'll give it 7. And because I'm lazy and I don't want to type, copy that. And we'll call this one low, this one norm, and this one's 8, and this one's 9. Okay, and inside setup, we'll go ahead and do pin mode, high temp LED, make it an output. Again, since I'm lazy, oh wow, good thing I caught that typo. Okay, got this all set to that. Now, let's do something with this. So, now after that tank in the loop, let's say we have T sensor dot get temp F tank is greater than 85 and I'm sorry, less than 85 and greater than, oh, I don't know, 80.01. Then we will digital right norm temp LED high. Else we will digital right norm temp LED low. So basically, if the temperature of the tank is between 80 and 85, we'll call it normal temperature, and again, we can set this to whatever we want. And if it's between that, it will turn the normal temp LED on, which is on whatever pin we set it to. Otherwise, it'll turn it off. Let's do if this guy, if that is greater than 85, we will digital right the high temp LED to high. Else we will basically saying if the tank is over 85 degrees, we'll turn on that high temp LED, otherwise it'll stay off. And since I'm lazy again, we can just copy that, paste it here. We can change this to be less than 80. We'll do the low. Obviously these aren't practical numbers for a reef tank, but I'm just throwing numbers in here for prosperity's sake. And that would be it. Verify it. It's good. Upload it. It's great. Now, what does this mean? Basically, we would plug in to the positive lead of 3 different LEDs, a high, which I use red, a normal, which I use green, and a low, which I use blue. So the high would go positive on the LED that you have on your breadboard, through a 330 ohm resistor, then to the high pin, which is 7 on the Arduino, and then ground leg of the LED to ground, and then repeat that for 8 and 9, and it works perfectly. If it's over 85, the red LED's on. If it's between 80 and 85, the green LED's on. If it's below 80, the blue LED's on. This is great. What matters more is this really is the framework for us to be able to set up relays to turn on and off outlets for heating and cooling. This is kind of just a little teaser on that. So that's it. That's it for this week. Thanks, guys.